Hello children, most welcome to all of you. In my previous lecture, you have studied about sigma bond, pi bond, how these bonds are formed, what are the definition of these bonds, and what is the main difference between sigma and a pi bond. You have seen in my previous lecture. And in the same way, we are going to study in today's video lecture in the same chapter, that is chemical bonding. We will going to learn about hybridization, one of the important part of this topic, hybridization. So we have studied here what is hybridization, what is the need of hybridization, and how hybridization can take part, and what are the important types of hybridization. These are all the points we are going to discuss in this lecture. So let's start with hybridization. Okay? So first of all, before commencing or going in detail of the hybridization, I would like to explain that you are knowing about valence bond theory, and according to valence bond theory, the covalent bond is formed by the overlapping of atomic orbitals, and in which only half-filled atomic orbital are take part in the formation of a chemical bond. Alright? So in the same consequence, one thing you have to notice that elements like beryllium, boron, or you can say carbon, if you write their electronic configuration in an orbital form, then you will get that their expected and observed balances gets deeper. Their expected and observed balances of such elements gets deeper. So due to difference in the balances of such elements, one concept was given, and that concept was given by an English chemist, Lord Pauling, in 1931, and the theory was called hybridization theory. And one more thing you should know, that hybridization theory is the theoretical concept introduced for the explanation of structure and geometry of the compound or geometry of the covalent molecule. Alright, so in the same, first try to know what the meaning of expected valency and what the meaning of observed valency. Then we will go ahead, and the topic will be hybrid orbitals and hybridization. So if you write the orbital configuration of beryllium, so it will come as, it will be, children, means 1s2, this is showing 1s2 and this is showing 2s2. In the latter part of this point, one thing I will discuss you, and you have to remember it more commonly, that in the case of hybridization, only there is a mixing of orbitals. There is no role of electrons. We have to notice here. So in the case of hybridization, means you can say hybridization is the intermixing of orbitals, not of electrons. So we will talk about orbital configuration. Okay? So beryllium configuration is this one. So according to valence bond theory, those orbitals which are fulfilled with electrons having valency 0. So the expected valency expected valency of element beryllium is 0 here because they have fulfilled orbital. But as we are knowing from the VBT or valence bond theory, beryllium is a divalent molecule. So means it forms compound like BeS2, BeF2 and BeCl2. They are what? They are bivalent. So according to this, bivalent means beryllium possesses the valency of observed valency of beryllium is 2. 2 points you have to understand here. Observed valency of beryllium is 2, but here is 0. So this is due to fulfilled. It is expected valency and 0, and observed valency because it exists in such forms means that it is a divalent. So its observed valency is 2. Similar, take part in boron also, children. If you write and here is 3 orbitals of p, 2px1, 2py1 and 2pz1. So one electron will be here. Alright. So according to the valence bond theory, its expected valency of boron will be here 1 because only one orbital is vacant having one electron, and so that valency of expected valency of boron will be 1. But it is a trivalent, means it exists as BCl3, BF3. So it is a trivalent. So its observed valency is not 1, is 3. Similarly, in the case of carbon, if you write, such condition will come, means such electronic configuration will occur. So here 2 electrons are unfilled. Okay, these 2 orbitals are unfilled, means having 1 electron only. So its valency is what? According to this, the valency, expected valency of this carbon will be here what? That is 2. But it is not right. We are knowing from the knowledge that carbon is a tetravalent and exists in the form of CH4 or form the compound like CH4, CCl4. Alright. So it is a tetravalent and observed valency of carbon is 4. So these difference in valencies creates many problems in the bond formation, and to explain these points, Lord Pauling explained it in the form of a hybridization. And hybridization, now come on the main point. Hybridization is the intermixing of orbitals, not of electrons, in which what happens? Mixing of orbitals as well as redistribution of energy take place and resulting the formation of new orbitals. Result the formation of new orbitals, which orbitals having almost equivalent energy, and that orbital are called hybrid orbital, and the phenomena will be called hybridization. So in order to explain hybridization, we have to know 2 configurations of this. Suppose this is beryllium 4Be, and it is if you are writing its electronic configuration in this form. So this form is called ground state configuration. Must remember, children, this configuration of beryllium is called ground state configuration. But if beryllium atom gets extra energy, and extra energy is denoted by that is steris. This is called steris. Okay, this symbol is steris. And during writing the electronic configuration in excited state, what will happen? Just see here. This is 2s and there is vacant 2 p orbitals are here. So one electron of this 2s2, one electron of this is 1s2, this is 2s2, one electron of 2s2 gets promoted in next vacant p orbital. So in this children, 1s and 1p, you are looking, see here, 1s and 1p, this is 1s orbital and 1p orbital will combine to form two new orbitals of almost equivalent energy, and that will called hybrid orbital, and the phenomena will be called hybridization. This is the meaning. So you have to write during hybridization excited state configuration. What is excited state configuration? Means the excited state configuration means the promotion of one electron of a lone paired or paired orbital to the next vacant orbital is called, that is excited state configuration or promotion of electron. Listen once more. Promotion of electron or excited state means when electron is present or atom is present in a ground state, it gets extra energy, then it gets excited, and the promotion of one electron of fulfilled orbital to the next vacant orbital. Here fulfilled, this orbital electron that is promoted into next vacant orbital is called promotion of electron, and that configuration is called excited state configuration. So must remember children, one hybridization can only take part in excited state configuration, and number of orbitals which are taking part in hybridization are called hybrid orbitals, and the phenomena is termed hybridization. So this is the concept of hybridization. Similar case occur here in the case of boron also. Listen, here is boron. Alright. So this is 5 electron is showing here. So when it gets extra energy, so this configuration which is written here is called ground state. But in excited state, what will happen? You have to make studies, and this one electron promotes into the next vacant orbital, and in this children you can clearly see that now 3 orbitals, 3 half-filled atomic orbitals are going to take part in hybridization, and they will result the formation of new orbital will be called hybrid orbital. So 1s and this is 2p orbital are taking part. So they will form 3. You have to write number 3. 3 new sp2 hybrid orbitals resulting gets formed, which energy will be almost equivalent to the previous one, and hybridization will be termed sp2. Similar case occur in the case of this is carbon. Means this electron gets promoted in such a way, and this configuration now become excited state configuration, and always hybridization will occur in excited state, and number of orbital taking part in hybridization is 4 here. So 4 new hybrid orbitals will form, which energy will be at least similar to the previous one. This is the concept of hybridization. So children, on the basis of this point, now hybridization can be defined as, so hybridization can be defined as, hybridization is the intermixing of orbitals and redistribution of energy among atomic orbitals, resulting the formation of new orbitals which are of almost equivalent energy, and such newly formed orbitals are called hybrid orbitals, and the phenomena is called hybridization. Alright. So must remember, hybridization is the mixing of orbital, not of electrons. So there are some features of hybridization. Listen and write sincerely. Some laws are features of features of hybridization. Hybridization. What are the features? First feature states that, or first point states that hybridization is the process in which there is a intermixing of orbital, not of electron. Second feature is the number of orbitals taking part in hybridization. Listen, the orbitals taking part in hybridization can be half filled or can be full filled. Okay? Third feature or third rule, write down. In hybridization, the number of orbitals formed. Listen, third feature or third rule of hybridization states that the number of hybrid orbitals or number of newly formed hybrid orbitals is just equal to the number of orbitals taking part in hybridization. And next feature or next rule you can say that in the hybridization only hybrid orbitals forms sigma bond, they never form pi bond. This is also a very important point. In hybridization, the hybrid orbitals only can form sigma bond, they never form pi bond. And one more point you can add here, that is hybrid orbitals having two lobes. Hybrid orbitals having two lobes, in which one lobe is a large lobe, and other lobe is called small lobe. And in bond formation, only large lobe can take part. For example, suppose this is your s orbital. Alright, make the axis, suppose x axis, y axis, z axis, and that going to combine with a p orbital. Make the axis, suppose x, y and z, and this is a p orbital, s orbital, p orbital. When they get mixed, when s and p orbital get mixed, what happens? So sp hybridization will take place, and they result as such. So in this children, this lobe, this is called large lobe, and this is called small lobe. So in bond formation, these large lobes only take part. This is the main concept of hybridization. So children, this is the definition, this is the features of hybridization. Now you have to study what are the types of hybridization. So hybridization is of 6 types. Hybridization is of 6 types. First is called sp hybridization. Second is called sp2 hybridization. Third is called sp3 hybridization. Fourth is called sp3d hybridization. Fifth is called sp3d2 hybridization, and last is called sp3d3 hybridization. So these are the types of hybridization which we have to study in detail. So in next lecture I will explain in detail that what are the sp, sp2 and sp3d3. So this is all about hybridization and their features and their hybrid orbitals. Remember them properly. So in next lecture we will discuss about the types of hybridization. So this is all about children's hybridization and hybrid orbitals. All the best. Thank you for joining us. Stay safe.